this problem, we are basically given a string S, and we need to rearrange the characters in this string such that no two characters are the same, basically. Like no two adjacent characters are the same. As you can see in this input, we are given A, B. We need to rearrange it in a way that these two A's do not come together. So it will just be like A, B, A. Um, and if there is no possible rearrangement, then we would just return an empty string. For example, in this case, there is no way we will rearrange it such that no two adjacent characters are the same. So we'll just return an empty string here. Okay. First thing that comes to my mind is basically having a map of frequencies of these characters so that so um, we can maybe solve this in a way where like we are tracking which character appears the most and basically trying to distribute it. So in each iteration, we would have to like pick the character that comes up the most, like that has the most frequency, so that we are done with the most impactful characters, basically, because like B occurring once does not have as much impact as A occurring twice or thrice in both of these examples. So first we can have a map. We will have a map in which we can have this character mapped to its frequency. And then based on this map, we can have a max heap. This is a priority queue that would contain a pair of it needs to return maximum frequency each time, so it would contain the pair of frequencies and characters. Yep, looks good. And while this heap is not empty, and okay, wait. Not just empty, I would say. Okay, what we can do is, so we have the map, we have this, and suppose this is our resulting string. Starts, okay. Now, what we can do is we will pop two elements every iteration from the max heap. So for example, if I have like C1, C2, I'll pop twice from the max heap top, and then pop, and then the same thing, maxi top, and then pop. We have both of these. Obviously, we will also have their frequencies as well. So we will like obviously pop the pairs. So for example, we have like F1 and C1, F2 and C2 popped out. And then we will append this C1, and then we will append C2 to our result. Doing this, we will ensure that no two characters are the same because we are popping twice from the maxi, and both of those times maxi is going to give you different elements because we have already once popped the most recurring element and then we haven't pushed it again to the heap yet, which we need to do. And since we are also getting the frequencies after they are appended to the string, like our resulting string, we'll see if we'll first increase the frequency. So and then we will check if this is greater than 0 or not, if like the character still exists or not. If yes, then we will push it to the max heap again as the pair of frequency and oh, yep, same with F2. And in this way, we will have like two characters in each iteration. So this needs to run while we have two characters, like while the max heap still holds two characters, which is basically max heap's size needs to be greater than or equal to 2. And then at the end, when it's not greater than or equal to 2, we will check if it's not empty. If it's not empty, then it has one character, basically. We can also check if if the size of this heap is 1, because if it becomes 0, then it's just empty. So it's the size 1 that we are mostly concerned about. Like, what if like all these characters are popped out and like two characters, and we have created a resulting string. But what if the last character, for example, what if the last remaining pair in the heap is something like 3k, for example? So this means 3 count for a character k, and this would result in an empty string because we cannot place k like thrice, and there is nothing to put alternatively between instances of k, so we will return an empty string in this case. So that's exactly what we need to check. uh, and if it's not empty, we will see if if it's something like 1 in place of 3, and like for example an element only occurring once, we are safe and we can just like append it to our string. So we'll see if uh, its top first is more than 1, and if that's the case, we will just return this, and otherwise we just add result this max heap top second, and yeah, we're good. I think that should be it, and at the end we just return result. So if we want to do a dry run with this, uh, our our map would become something like, okay, I guess we can do it for this. Our map would have a b. A is 3, b is 1, and then in the maxi we will have 3a on top and then 1b. We retrieve both these elements, so these become c1 and c2. We append both a and b to our result so far, and then we decrease its frequency. This becomes 0, this becomes 2, and now only this goes to the heap. Push to heap, and when this is pushed to heap, the size of the heap is not 2 anymore or greater than 2. So we come to this, and when we come here, we check if the top element, which is basically here it will be 2a, we check if this is greater than 1 or not. Here it is, so we will just return this, and which is correct since this cannot be rearranged in the way that the question asks for. And that's it. Let's move on to the code.
Okay, now let's solve the actual problem with the actual code. First we will, first we will have map of frequencies in which we are storing each character mapped to its frequency. So it is just going to be an unordered map of character. We can just name it frequency, and for this we will have character c in our string, and we will basically then we will have our max heap containing frequency and character pairs. So for the max heap, we need to make sure it's a pair, and I'm just going to name it PQ. This is priority queue. And then for CF in frequency, for each pair in frequency, we will PQ push it as FC. Yep, and then we have our string. We need to return a string as a result. So this is a string initialized to nothing, and we will run the loop until the size of this max heap is greater than or equals to 2. Now we will have the frequency and character pairs up top, and then EQ pop. Again, for this, we will have sorry, I don't think we should be doing this since we will be changing the frequency. So again, leetcode and then this. Now we will append C1, then we will append C2, and then we will decrement F1 and check if it's greater than 1. If yes, then we will push it back to the heap. In the same way, we will check if decreased F2 is still greater than 1. If yes, we will also push this back to the heap, and once the size becomes less than 2, we'll see if we want to make sure the heap is not empty, and if it's not, we will again check if the top element of the heap's frequency is greater than 1 or not. If it's greater than 1, we will simply return an empty string, as it won't be possible, and if not, we will just append the max, it's top second, and that should be it. Last element in the heap. Okay, let's run it to see if there are any errors. There is. Wait, so there is an error. We had A, we increased A's frequency here, and it was 2, it was pushed here, and then we take out A and B both. Oh, sorry, this needs to be greater than 0, never mind. Yep, and now we submit. Let's see. Oop. Okay. This. Oh my god, that was such a foolish mistake. Now it should be good. And yep, that's it. The time complexity should be the heap building. It takes like log k time, but if you think about it, we only have 26 characters, so it's just going to be O of n, and space complexity is going to be O of n again for the map and the heap. And yeah, that's it for the solution for reorganize string. Thank you.